Hello everyone, welcome to our practice exercise 4, and in this practice exercise we'll learn more about the SQL queries, views and aggregates. And in this exercise we aim to give you the practice in asking SQL queries on relative simple schema using the SQL aggregation and grouping operator, writing SQL view definitions and porting SQL across multiple data management systems. And in the following practice questions, we will all use the background using this ER diagram. So let's look through this ER diagram first. So we have four entities here. They are the brewer, bill, drinker, and bar. Each of these entities have their own primary key ID. So we have for example, we got the brewer ID, the drinker ID, bill ID, and bar ID, right? Then between each of the pair of the entities, we got some different relationships. For example, this makes. So this one is one-to-many relationship. So that means we do not need an extra table to represent this relationship. But for the likes, for the sales, and the frequency, both of them, all of them are the many-to-many relationship, right? So we will need an independent table to represent this relationship respectively. Okay, so if you want to practice the following SQL question in the real environment, you may copy the schema SQL into your local storage, and then we can then drop the original build2 and create the new build2 database to practice the following questions. Okay, then so we will also talk a little bit about the SQLite database in the end of our in the end of this in this video, but not very much, and we will learn the difference between the SQLite database and the PostgreSQL database. We will have 25 questions in total in this practice, but for the question 1 to question 17, we have already covered this similar question in the previous practice exercise. So today we will start from question 18. Okay, so question 18, which bar is the most popular? And its definition is the one with the most drinker. Okay, so we will first to create a will to say here, like we have count the name of the bar and count the number of the drinker for each of the bar, because we want to do the aggregate function here, which is a count. So we will do the group by here, right, by the end of this query. And here is a note. If we want to do the aggregate function, we only exclude what we have included as the aggregate function, and everything else should be included in the group by after the group by. Okay, so here we got the select the name from the bars table and count for each drinker, and according to our ER design, we will link the bar table and the drinker this column by link the bars table, frequency table, and drinkers table together. And why we use the left join here? Because we want to keep all the information for the bars. We want to get all the information with the name, right, of the bar name, right? So we use the left join here. Okay, so by joining these two tables together, we will get the number of the drink for each bar here, like this. So we have the most number of 2. So now we will use this wheel to help us to get number of drinker equal to the maximum number of the drinker from this wheel we created. Okay, so we will have Lott and Nielsen, Coogee Bay Hotel, which got the most number of the drinker, right? So that is for question 18. Question 19, which bar is the least popular, may have no drinkers? So that means even if there is any drink, any bar without any drinker, we should select it out. Because we already used the left join here, and all the bar got at least one drinker. This is what we have in the previous question. So that means in the question 19, we can directly use the view we just created. So we will have the local tap house, Maple bar, and blah blah. Okay, so that's for question 19. 20, which bar is the most expensive? That means have the highest average price. So first we need to create a view to help us know the average price for each bar, right? Okay, so the average price is coming from sales table, and the bar's ID is coming from the bar table. So we need to join these two tables together, and here we want to do the average on the sales price, right? So we got the average sales price and give it a data type called numeric 52 as the average price. So this means we will have 5 digits in total. That is the maximum length of this number, and there we got a decimal point, and there are two lengths of 2 digits after the decimal point. So that is what the meaning by this numeric. Okay, so after we have this view, we can then use this view to get the maximum average price from this one, right? So we do a subquery to select the maximum average price from this one, or we can also use to select all the average price like this, and make it, because it should be the max price, so we let it larger than all the price in this list. Okay, cool. Let's have a look at the result. So we will have a bar called local tap house, which got the most expensive one. Okay, so then question 21. Which bars are sold which beers are sold at all bars? So this question is a little bit similar to what we have in the tutorial. And this one we may introduce that the exist, not exist, and except. So we know that the exist means for a set, the things exist in this set, and the except means if we do our like this. So if this is set A, this is set B, then set we exist in A except B means what we have in this part. Okay, so now this one, select ID from the bars, all bars. So that means the set A for, in this case, is the bar's ID. In the set B is the bar for sales ID. Okay, for the sales. So this one is the beer. So that means we have the beer. For example, we have beer 1, 2, 3, 4, 5. Then this bar got provide 1, 2, 3. Then that means this bill, we got the bar list is 1, 2, 3, and the bill number of 1, 2, 3, 4, 5. That means we will have this bill not provided in bar 4 and 5. Okay, so this bill is not provided in 4 and 5, then that means which is not exist, right? So it exists, is not empty, so that means this bill is not provided by all the bar. Okay, so we will join bills and sales table together and to select all the bars ID and the bills ID by like this, and do something to filter out any bills not provided by all the bars. So let's have a look. Okay, so the final answer is there's no bill are sold at all bars. Okay, so that is question 21. Then question 22, the price of the cheapest bar bill at each bar. So we want to select all the bills price from the each bar and select the minimum price, right? Okay, so let's create the temporary view first. The bar's name, we got it from the bars table, and the minimum price is coming from sales table, so we would like to join these two tables together. Then we do a grade function by get the minimum price here, and the numeric is 5 and 2, as what I explained in the previous question similarly, right? Okay, then we finally group by the name of the bar. Okay, then we will directly get the minimum price of each bar. So we just select the view and get these two columns information. Should be enough then. Okay, so we will get this one. The Regent Hotel got 2.2, and the Maple Bar is 2.8. Royal Hotel got the 2.3, and blah blah. Okay, so the order may be a little bit different. That because our database have a little bit update after we get this answer. Okay, so it doesn't matter. If we want to do it's like following by a certain order, then we can directly ask it order by, right? Order by the bar name, and because we want it like ascending order, so we will use ASC here. Okay, then all the information in this table will be sorted by the bars column in the ascending order. Okay, number 23, name of the cheapest bill at each bar. Okay, so because we have already got the minimum price, but we haven't got the bill's name, so then we would like to a little bit add it on the previous answer. We will do like this. Okay, so we will get the price from the sales table and the bill's name from the bills table. So we join the previous bill minimum price this view and with the two other tables here, then we will select the minimum price from each of the bar in the subquery to get the filter. Then we will get all the cheapest bill at each bar, right? Okay, so let's check. So we will have Australia Hotel, new, and each of the each of the bar will give the name of the cheapest bill. So we have two Regent Hotel here and two Royal Hotel here. That means, and also the Maple Bar. That means these two bills get the same minimum price in these bars. Okay. Number 24. How many drinkers are in each suburb? So this one we will simply make use a group by and count the number of the drinker from the drinks table. So we'll get the answer. For Mooseman, we got 1 drinker, Clovelly 1 drinker, Newton 1 drinker, and then finally the Runway got 1 drinker. Okay. Then the last question, how many bars in the suburb will drinkers live? So we will get the address and the bars and the drinkers. So we will combine the drinkers and the bars table together. That means we join them together. So we join the drinker and do the left join of the bar table B, and by this is how we join the table. And here we got the number of the bars. So this hash means the number of. Okay, so we do a count. Count is aggregate function. So remember that we need to include this in the group by. Okay, let's check. So we have the Mooseman, Newton, Clovelly, and the Runwick, and which one we got 1. And because we have here must include suburb with no bars, so that means we use the left join to keep everything of the address of the drinkers. Okay, so we keep everything in the address. So why we use the left join. Okay, then that's all the practice questions for practice exercise 4, and we also provide the sample solution here. But I really suggest if you want to increase your SQL query skills, then you can try to finish all these questions by your own first, and then we can look at the sample solution. Okay. Then the last part of our this video, we will introduce about the SQLite. So in the SQLite, it is a little bit different from the PostgreSQL. It's like a light version of the PostgreSQL. So that means it may not as smart as PostgreSQL. So if we create or replace something like what we did here in the PostgreSQL, it will be not illegal for this SQLite. So what we can do in the SQLite is the drop wheel if it exists. So this is a more commonly used sentence, and then we create a new view. Okay, so this is like we have to drop it and to create a new one instead of we can directly replace it. Okay. And for this one, if you use the Vim, this is the editor, and following the command will convert all the current create view statement into the proper form. That means we can simply change all the create or replace view by the drop view exists and create a new view. And this one is a variable, so we will make it so this means we will have the variable, the question number here. So achieved by typing 2 character sequence, Control V and Control M. So then we will got a little arrow in front of the M. Okay, then to avoid the fact that SQLite doesn't support view definition, the form we will, for example, we will do like simply use the equivalent form, we will do like this. So we cannot make these two have different names like this. We have to ask it to let it know what the real name of the variable we use it here, or the column name we use it here. We have to make it consistent. Okay, so that is what we will do in the SQLite. And one problem, the SQL do not have the quite same formatting option for the result view. So Postgres SQL allows us to cast a numeric value to control the number of the decimal place in the real number value. So we will not use the numeric, this data type, in the SQLite. Okay, so that is the limitation of the SQLite database. Okay. So the simple solution of the SQLite will be also provided here, and you can have a look. And thank you for watching this video. Bye.